Hello students, welcome back to my channel. In this video I am going to share chemistry solutions test series 12 key based on ESET 2024. What volume of 0.8 molar solution contains 0.1 mole of the solute? So here we are supposed to calculate the volume. So what is the relation between the molarity and the volume of the solution? Molarity is equal to number of moles divided by volume of the solution in liters. Here the number of moles is equal to 0.1 and here we are supposed to calculate the volume. So molarity is given, that is 0.8 divided by V. That implies V equal to 0.1 divided by 0.8, that is equal to 0.125 liters. That means it is equal to 125 ml, and hence the right option is option B, that is 125 ml. Molarity of 0.5 normal phosphoric acid is, the relation between normality and molarity is, normality is equal to molarity into n factor. So here we are supposed to calculate the molarity. So molarity is equal to normality divided by n factor. The formula of phosphoric acid is H3PO4. So it is possible to replace 3 hydrogen atoms and hence n factor for phosphoric acid is 3. So molarity is equal to, here the normality is 0.5 divided by n factor is 3, 0.5 divided by 3, that is equal to 0.166, and hence the right answer is option D, that is 0.16. Coming to the third question, the concentration of 0.5 molar sulfuric acid is, already the concentration is measured in molarity. That means we have to calculate the concentration of the solution in terms of normality. So normality is equal to molarity into n factor. What is the formula of sulfuric acid? That is H2SO4. So in the case of sulfuric acid, it is possible to replace 2 hydrogen atoms and hence n factor is 2, 0.5 into 2, that is equal to 1. So the concentration of 0.5 molar sulfuric acid is 1 normal. So option A is the right answer. Which of the following method of concentration is independent of temperature? Molarity and normality will be calculated for solid in liquid system, whereas mole fraction is calculated for solid in solid system. So especially solid in solid systems will be independent of temperature. So here the right option is mole fraction, that is option C. In a binary solution, sum of mole fraction of two components is, binary solution means it consists of only two components, namely solute and solvent, and always the sum of mole fractions of the two components is equal to 1. Hence option B is the right answer. What is the volume of 0.1 molar sulfuric acid required to completely neutralize 1 liter of 0.5 molar NaOH? So here the concentration is expressed in terms of molarity, and here sulfuric acid is titrated against NaOH solution. So it is best example for acid base titration. So let us calculate how many moles of acid is required to neutralize sodium hydroxide. So acid reacts with the base and results in the formation of salt and water. So on balancing the equation, it is very clear that 1 mole of sulfuric acid is required to neutralize 2 moles of NaOH. So, in the case of volumetric titrations, we use the expression M1V1 by N1 equal to M2V2 by N2. Here, M1V1 N1 is given for acid, M2V2 N2 are for the base. So, we are supposed to calculate what is the volume of sulfuric acid is required. That means, we are supposed to calculate V1, that is equal to M2 V2 by N2 into N1 by M1. That implies V1 equal to, let us substitute the values. So M2 is 0.5, V2 is 1 liter, N2 is equal to 2, N1 is equal to 1 divided by M1 means it is 0.1. So, on calculating, we will get V1 as 2.5 liters and hence the right option is option B, 2.5 liters. 40 grams of sodium hydroxide is dissolved in 90 grams of water, then mole fraction of sodium hydroxide is. Here sodium hydroxide is the solute that is dissolved in water. Water is the solvent. So, for calculating the mole fraction, initially we have to calculate the number of moles of sodium hydroxide and also water. So, coming to the number of moles, it can be obtained by calculating weight divided by gram molecular weight. Here the weight of the sodium hydroxide is given as 40 and the gram molecular weight is 40 and hence the number of moles of sodium hydroxide is equal to 1. Coming to N2, that is the number of moles of water. Weight of water is 90. The gram molecular weight of water is 18 and hence that is equal to 15. So mole fraction of sodium hydroxide is given as the number of moles of sodium hydroxide divided by total number of moles of the solution, that is equal to 1 divided by 1 plus 5, that is equal to 1 by 6 and hence it is equal to 0.166 and hence the right option is option D. A saturated solution on heating becomes, so whenever if we consider a saturated solution and that is heated, then what happens? Saturated solution means it contains maximum amount of the solute. But on heating the saturated solution, it becomes capable of dissolving more solute. That means it becomes an unsaturated solution. So, a saturated solution on heating becomes unsaturated solution. So, option C is the right answer. The weight of silver nitrate present in 100 ml of 0.25 molar solution is. So, formula for calculating weight of the substance is weight is equal to molarity into gram molecular weight into volume in ml divided by 1000. Here the molarity of the solution is 0.25, gram molecular weight is given as 170, volume of the solution is given as 100 divided by 1000 and it will become 4.25 gram. Hence option A is the right answer. The following concentration method has no units. Mole fraction is the ratio between the number of moles and hence it has no units. Option C is the right answer. A binary solution contains equal number of moles of the solute and solvent. Then mole fraction of the solute and solvent are. So binary solution, in the case of a binary solution, the mole fraction, sum of the mole fractions of solute and solvent is equal to 1. Here the number of moles are equal. That means x1 is equal to x2 equal to 0.5. So option A is the right answer. Which of the following solution has same molarity and normality? So here the given options are sodium carbonate, sodium hydroxide, sulfuric acid, potassium permanganate. Especially monoprotonic acids or bases will have same molarity or normality. Simply, if you consider any substance in which if the charge of the cation is equal to anion, that is equal to 1, then exactly the molarity is equal to normality. In this case, option B, that is sodium hydroxide, is the right answer. The normality of 0.1 molar sulfuric acid is, here normality is equal to molarity into N factor. In the case of sulfuric acid, N factor is equal to 2. So that is equal to 0.1 into 2, that is equal to 0.2 normal. Hence option A is the right answer. The weight of potassium chloride in 100 ml of 0.1 molar KCl solution is, weight is equal to molarity into gram molecular weight into volume in ml divided by 1000. Here the molarity is 0.1. Gram molecular weight is 74.5, volume is 100 divided by 1000. On calculating, it results in the formation of 0.745 gram. Hence, option C is the right answer. The weight of sodium carbonate required to prepare 250 ml of 0.1 normal solution is. So, for calculating weight, when the concentration is expressed in normality, that is equal to normality into gram equivalent weight into volume in ml divided by 1000. So here the normality is 0.1. In the case of sodium carbonate, the gram equivalent weight is 53, volume is 250 divided by 1000. So on calculating, it results 1.325 gram. So option D is the right answer. Soda water solution is an example of. So it is an example of gas in liquid system. So option A is the right answer. The weight of potassium permanganate required to prepare 100 ml of decinormal solution in acidic medium is. In acidic medium, potassium permanganate will gain 5 electrons and hence its equivalent weight is can be calculated. Weight of potassium permanganate required to prepare 100 ml of decinormal solution in acidic medium is. In acidic medium, potassium permanganate gain 5 electrons and hence its equivalent weight is equal to 158 divided by 5, that is equal to 31.6. Decinormal means 0.1 normal solution. Weight can be calculated by using the formula normality into gram equivalent weight into volume in ml by 1000. That is equal to 0.1 into 31.6 into 100 divided by 1000, and that is equal to 0.316 gram, and hence the right option is 0.316 gram, that is option D. 10 ml of 10 normal HCl solution can be diluted to decinormal solution by adding how much volume of water. So initially 10 ml of 10 normal HCl solution is taken and it is diluted to decinormal solution. So here we have to use the dilution formula N1V1 equal to N2V2, and we are supposed to calculate how much water is added. Before calculating the volume of water added, we have to calculate what is the final volume of the solution. Here N1 is 10, V1 is also 10, N2 is decinormal means 0.1, and we have to calculate V2. That implies V2 is equal to 100 divided by 0.1, that is equal to 1000. So the final volume of the solution is 1000. And how much water is added to 10 ml of the HCl solution? So volume of water added can be calculated by using the expression V equal to V2 minus V1, and that is equal to 1000 minus 10, hence that is equal to 990 ml. Hence, option B is the right answer. The molarity of a solution obtained by dissolving 0.01 moles of sodium chloride in 500 ml of the solution is. So, molarity is equal to number of moles by volume in liters. But here the volume is given in ml. So, we have to divide it by 1000. So, that is molarity is equal to the molarity of a solution obtained by dissolving 0.01 moles of sodium chloride in 500 ml of the solution is. So, molarity is equal to number of moles by volume in liters. But here the volume is given in ml. So, we have to divide it by 1000. So, that is molarity is equal to 9.8 grams of sulfuric acid is present in 2 liters of a solution. The molarity of the solution is. Molarity is equal to number of moles by volume in liters. Here the number of moles can be obtained by calculating weight divided by gram molecular weight, that is 98 into 2. Volume of the solution in liters is 2. So that is equal to 0.5, and hence option B is the right answer. A molar solution is one that contains 1 mole of the solute in. So 1 mole of the solute is present in 1 liter of the solution, and hence option C is the right answer. The molarity of the solution containing 1 gram of sodium hydroxide in 250 ml of the solution is. So here molarity is equal to weight by gram molecular weight into 1000 by V in ml. So that is equal to 1 by, here gram molecular weight is 40 into 1000 divided by 250. Hence it is equal to 0.1. So option B is the right answer. Which of the following is true for a solution of a sugar in water? Option A, sugar is the solute. Yes. Water is the solvent and it is an aqueous solution. So option D, all the above are correct. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day. The molarity of 4% NaOH solution is. 4% means 4 gram of NaOH is dissolved in 100 ml of the solution. Hence, molarity is equal to weight by gram molecular weight into 1000 by V in ml. So, that is equal to 4 by 40 into 1000 divided by 100. Hence, that is equal to 1 molar. So, option D is the right answer.